So for number 10, we want to prove several statements, and what we're using is these definitions. So we have a graph is an ellipse if it meets these conditions, a parabola if it meets the middle one, and a hyperbola if it meets the other one. So for item A, it's asking us to prove that the graph of equation is an ellipse. So here we would be on the first one. Whenever A is greater than C is greater than B is greater than 0. Now, this is of the form Q whenever P. And we just have to remember that when we see Q whenever P, it does mean that P implies Q. So it's of the form actually P implies Q, right? And so because we have Q whenever P, it does mean that the hypothesis is going to be this guy right here. So that is our hypothesis, and our conclusion is going to be this guy here, right? So what I've gone ahead and done, is just put our hypothesis, so assume that A greater than C, greater than B, greater than 0, and I've also put the conclusion because I know that it wants us to prove that the graph is an ellipse. So the conclusion must be that b squared minus 4ac is less than 0, right? Which meets the first criteria here. And so if it meets that criteria, the graph is an ellipse. So what we're going to do here is just kind of work backwards a little bit just so that we know how to manipulate the hypothesis. So here we have that b squared is going to be less than 4ac. So what I need here is I need to compare b squared. So I need to compare b to 4ac to begin with. So let's take a relationship between a and b. So I have here that a is greater than b. So what I'm going to do here, is I'm going to multiply both sides by c because I do want to compare b to ac, right? And when I multiply both sides by c, because c is positive, it doesn't change the direction of our inequality. So I have that ac is greater than bc. Okay. Now, I also need to be able to relate c to b, right? Because I have bc, and I don't want bc, I want b squared. So I need to be able to relate bc to b squared. So I have that c is greater than b, and what I'm going to do here is multiply both sides by b, and once more b is positive, so it doesn't change our inequality. So I have that bc is greater than b squared. So once I have this, I've pretty much established that. Actually, I should have done one thing here. I should also have established that AC is greater than BC, but we don't want AC, right? So this means that 4AC is definitely greater than BC, because if AC is greater than BC, then so is 4AC. So once we have this, what do we have? We have that 4AC is greater than BC, which itself is greater than B squared, right? So what this means is that 4AC, I can just cut out the middleman, that is greater than B squared, which implies that b squared is less than 4ac. So we were at the point where developing from the conclusion meets developing from the hypothesis, and that is our proof. It is done. So let's go now to item B. So item B, we have here, we're going to have also a conditional, right? P if Q, and our hypothesis is going to be, let's see, our hypothesis is in green. It's going to be if AC is less than 0, or B is less than C is less than 4A is less than 0. And so that's going to be our hypothesis, and our conclusion is going to be this. So let's change it. So our conclusion is going to be that, therefore, the graph is a hyperbola. And what we're looking for when we're talking about a hyperbola, we're looking for the third condition here. We're looking for b squared minus 4ac is greater than 0. So that's what we're looking for. And let's see what else. Now we need to change our hypothesis as well. So our hypothesis is either that ac is less than 0, or we have that b is less than C is less than 4A is less than 0. So this does mean that we do have to break it down into cases, right? And actually, I'm just going to expand that this I want that b squared is greater than 4ac because that one is easier to visualize. Okay, so let's do case 1. So we have here that case 1, in case 1 is when AC is less than 0. Well, if you look down here at our conclusion, we're looking at 4AC, right? So let's get 4AC. So this means that, so 4AC must be less than 0. Actually, maybe I'm afraid that I'm gonna run out of space, but let's try. So that means that 4AC is going to be less than 0. Okay, so once I have that 4AC is less than 0, what else do I have? I have that B is a real number. So B squared must be greater than or equal to 0. But we have that 4AC cannot be equal to 0, right? It's less than 0. So if 4AC is less than 0 and B squared is greater than 0, our conclusion is that B squared is greater than 4AC, and so B squared minus 4AC. So we have shown that we meet the first part, right? And what about case 2? In case 2 is that when B is less than C is less than 4A is less than 0. Okay, so now what are we going to do here? Well, let's begin with the fact that B is less than C, right? Because I want to be able to relate B to C. So in this case, I have that B is less than C. So what am I going to do with this? And actually, I'm going to make some space by just moving the stuff a little bit lower here. Okay, so what am I going to do with case 2? Well, B is less than C. And so what we're going to do here is we're going to multiply both sides by 4A because I do want 4AC, right? That helps us, that gets us closer. However, 4A is less than 0. So if I multiply both sides by 4A, it's going to change the direction of my inequality. And so I have that, let's see, 4AB is greater than 4AC. So that's my first part. I do have 4AC. And now let's look at it in a different way. So I have that B is less than 4A, right? Now let's try to get B squared here. So if I multiply everything by B, B is less than 0, so it's going to change the direction of my inequality, right? So I have here that B squared is going to be greater than 4AB. So once I have this, I have that B squared is greater than 4AB, which is greater than 4AC. So I can just cut out the middleman and say that B squared is greater than 4AC. And in this case, B squared is greater than 4AC, so B squared minus 4AC is greater than or equal to 0. Minus 4AC is greater than or equal to 0. So what I've shown here is that, I forgot this. So what I've shown here is that in case 1, I have that B squared minus 4AC is greater than or equal to 0. And in case 2, I have that B squared minus 4AC is greater than or equal to 0. So we can say that in both cases, B squared minus 4AC is greater than 0, and therefore the graph is a hyperbola because it meets this criteria here, right, of the third line. And so I've shown that with cases, no matter what, it's always going to get to B squared minus 4AC is greater than 0, and that is it for item B. Now let's go to item C. So let's go to item C. And item C is a little different because item C begins with the assumption that the graph is a parabola. So we have the form if P then Q, where P is the assumption that if the graph is a parabola, right? So that's our P. Then Q, then this stuff happens. So for C, assume the graph is a parabola. graph is a parabola, we're going to be here in the second line, right? Then it means that, actually I shouldn't use then, I should say if and only if b squared minus 4ac is equal to 0, and thus b squared is equal to 4ac. So what is it that we want to prove? We want to prove that either bc is equal to 0, or that b squared divided by, or a is equal to b squared divided by 4c. So let's consider case 1. Case 1, where c is 0. Well, if c is 0, then bc is equal to 0, right? That's not very complicated, so we have shown the first part. And what about case 2, where c is non-zero? Well, if c is non-zero, it means that we're allowed to take b squared is equal to 4ac, and we're allowed to divide everything by 4c, right? So b squared divided by 4c is going to be equal to a, which I wouldn't be able to do if c were 0, because then I would be dividing by 0. And so once more, I have shown what I needed. So in either case bc is equal to 0, or b squared over 4c is equal to a. And so in this case, we have shown that if the graph is a parabola, then this conclusion necessarily follows. And that is it for number 10.